Hello students, this lecture is on the kinematic equations. Basically it's talking about velocity and acceleration together. So when you combine your velocity equation, v equals d over t, okay, you also can combine acceleration equations. So they basically call them the kinematic equations, and there's several of them. So the first one here is when constant acceleration. So constant acceleration is acceleration that doesn't change over time. So you basically have the first equation, which has to deal with the velocity equation and the distances over time. So the initial displacement, this is to find the final displacement, how far you've traveled. Basically we rewrite that, right? Because you have so you can write it as the final distance is equal to the original distance plus the velocity times time. The second kinematic equation is basically, you can find velocity, or the average velocity is you add them up. So you have the initial velocity and the final velocity, and you divide by 2. That equation we don't really use as much. The third equation is definitely one we're going to use. Now this is an equation that we're combining. You're taking the acceleration equation, that's a is equal to v over t, but now we're rewriting it to find the final velocity. So velocity would equal the original velocity plus the acceleration times time. The fourth kinematic equation is now a combination of the velocity equation and the acceleration equation. So when you combine them both in, you're basically getting, you can find that the final distance is equal to the original distance plus the original velocity times time plus 1/2 of the acceleration times the time squared. I can find a link and show you how this gets derived, but I know for most of the students in this class, you just basically get lost in the explanation. So I just want to approach this as these are the given equations, and then we're going to start to do some problems. When you have this equation dropped down to a is equal to 2 times d over t squared, when you start from rest, which means the original velocity is 0, so this whole thing leaves and this whole thing leaves. The only thing I don't like is it also means that a d equals 1/2 at squared. And they rearranged it and solved for a. One of the last equations is involving velocity, acceleration, and distance, and that's when you don't have the time given in the problem. You have the final velocity squared is equal to the original velocity squared plus 2 times the acceleration, and then in parentheses it's basically the change in distance. We're calling that the displacement. So this is when it doesn't have the time. Now if you start from rest, that means that v0, this just basically goes out of the way, and d0 would be 0. So you're left with v squared equals 2ad. And so just to confuse you, the book is rewriting the equation as a equals. There's your moving man. So here's your equations right here. So the first equation is when you have the distances, velocity, and time. The second equation we'll rarely use, but that's your average velocity. The third equation is one we will use a lot. That's when you have velocity, time, and acceleration. The fourth one is when you have velocity, distances, time, and acceleration. This one's used a lot. And then the fifth one is when you're trying to find stuff but they gave you no time. And so in using these equations, this book starts talking about problem solving equations, so go back and look at my problem solving steps that I do. But there, I'm going to be going over some other equations to do, or possibly we can do some of these practice problems. So look in the next lecture for that.